Hello, everyone. Good afternoon. Can you all hear me? Okay, good, great. Okay, so this afternoon, this will be our last session together. All right, and what I'm going to do with you is to revise back the four topics on intersection as well as pedestrian. And I've already mentioned to you, I think, on Tuesday, that railway system is not included in the final assessment, so therefore we'll not revise that topic. Okay, so I'll go through with you on this, and then I'll speak a little bit on the format for final assessment. And if you have any questions, please feel free to post it in the chat, or you can also unmute yourself and talk into your mic. All right. Okay, so we have gone through on Tuesday, we have gone through the first 3 weeks, the first 3 topics. And if we look broadly into these first 3 weeks, the topics revolved around transport planning, transport modeling, how we get the data for transport planning, how we estimate the traffic in the future. Okay, and how we manage the traffic so that it is not so congested. So at week 4 onwards, week 4, 5, 6, 7, we look at intersection. So now we are zooming into traffic engineering, which is on the intersection, how we analyze the intersection, how we look at the intersection, how we treat the intersection, and how we design the intersection. All right. So if we look at week 4, we discussed on at-grade intersection. And at-grade intersection, in the first part, we just look at how we use channelization, unsignalized intersection, channelization to treat the intersection. Yeah? We are not dealing with design, sorry, we are not dealing with analysis yet. We are just merely doing the design and the ideas for treatment, yeah? Intersection treatment, okay? So we have different types of treatment that we can use, plain type flaring, channelization, all right? And channelization also, we have different forms. You can have just painted markings or raised traffic islands. So all these, the idea of doing treatment, be it whatever form it is, the idea of doing treatment to the intersection is so that traffic is smoother and we create lesser number of conflict points. So that traffic is smoother and it is, in terms of safety, it is safer because we minimize the number of conflict points. Right, yep. So we discussed on the conflict points. We want to minimize the number of conflict points, and therefore we put in we put in intersection treatment. Okay. So likewise, I think you have done that in your assignment 1 as well. You have already treated your intersection with at least 2 unsignalized, and then you have the other one around about. Okay. All right, so yep, so we have different types of traffic control devices. Right, so the objective of doing intersection treatment, intersection design is always 2. One is for the capacity, okay, to increase the capacity, and the other one is in terms of safety. Yeah. It's always these 2, depending on where the intersection is. Then we provide for either one of these 2 or both at the same time. Yeah. So usually urban areas, arterial intersection, usually it is meant for capacity, but of course we have to cater for safety as well. But mainly the focus is on capacity. Okay, towards the lower level, roads with lower hierarchy, local roads, usually we want to cater for safety, not so much for capacity. Okay, safety as well as pleasantness of your residents in that area. Okay, and for rural intersection, speed is high. We usually look at safety issue rather than capacity. Okay, so it always revolve around either capacity or safety. Okay, so then yeah, reducing number of conflict points, and separation of conflict points. When we did the channelization topic, what we want is to give a very clear, to show a very clear roadway to your users, particularly to the drivers, of where they are supposed to go, and not just move any way they like. Okay, so this is realignment. In this case, is lowering the number of conflict points by having a clear direction of where they are supposed to go. Okay, so various forms of treatments that we have: realignment, putting the conflict points, separating the conflict points into two, although this may increase the number of conflict points, but what's that? This would be better because the conflict point here, the diverging is two, so this is two different directions. So it is less severe if there is any untoward incident were to happen. Okay, this is also separating the number of the intersection. And we see that this is 9 conflict point, 9 conflict point. This one intersection is 32 conflict points. Okay. Yeah, so we also want to minimize the area of conflict because we don't want the drivers to drive any way they like. We want a very clear path for your drivers to follow. Okay, so treatment idea is also because of this. Yeah? We want the drivers to be very sure which lane they are traveling in, where they should be traveling in. Okay. Right, and earlier on I said in terms of capacity or safety. So this is in terms of safety, to control the speed. The way how we design the intersection also helps to control the speed. So in case any accident happen, the chances of survival are higher. Okay. And when we do intersection design, when we do channelization, we always have to back it up with some other, some other appropriate traffic control devices, because line marking alone, intersection alone, will not be able to create a safe environment for your users. So therefore, we have to enhance it with other traffic control devices, okay, so such as line marking, signage, posts. All right, so that would help. Okay, so this was also done in your assignment 1, where after you have already designed, where after you have already designed your intersection, you also put in, I hope you also put in signages to help your drivers so that they know where they are supposed to go. Okay. All right. Okay. Then, yeah. So what are the factors affecting your intersection design or treatment would then depend on, back again to the objective just now, safety and capacity. Okay. So in terms of capacity, we look at the number of volumes, composition of traffic on each approach, okay, the classification of the intersecting roads. All right, so this is also designing for capacity, and then the speeds. This will be for safety. Okay, vehicle approach speed will be designing for safety. The presence of over-dimensional vehicles. This would be for in terms of capacity, but also in terms of safety. Okay. estimated delays to major and minor movements and to pedestrians. So this is related to capacity. All right. So it's always revolving around that too: capacity, safety. Okay, yep. So some considerations here: pedestrians, over-dimensional vehicles, public transport. Okay, and then we have site conditions that we need to fulfill. These are not so much of whether it's safety or whether it is capacity, but these are the controlling external factors that will influence our design or our treatment type. Okay. So accident experience is definitely related to safety. Okay, so then we move on to discuss channelization. More of this role of traffic islands, whether it's painted or raised traffic islands. Okay. Yep. So all these were incorporated into your assignment. And then we look at the various major types of intersection treatment or intersection control, starting with T intersection, cross intersection, and multi-leg intersection. Okay, so T intersection, very basic. It's quite easy to treat. If the angle is not correct, then we can treat it to modify the angle a bit. Okay. So these are again various treatments. Example, and to treat the T intersection with a roundabout. And again, the T intersection, we have to see where it is located, whether it is urban, rural, if capacity is an issue. So we have to see what's the underlying issue of that intersection before we propose the treatment. Okay. Okay, and then we have cross intersections. Treatment-wise, we can use a staggered T treatment, wide, median, roundabouts, and signalized. Okay, so staggering means instead of a instead of a cross intersection, we will divide that into two, separate the intersection into two T intersections. Okay, and we always prefer right-left stagger, right-left stagger, so that this is a right-left stagger. Okay, so little land acquisition compared to a roundabout, and for a right-left stagger, you don't need a waiting space in the on the line or is that on the lane here, on the major lane, because once if you can turn right, then you should be able to turn left into this road. So you minimize the waiting space required on the lane here. Okay, then we have wide median, wide median. Yep, so this is about 30 meter, very wide median, and the traffic will be able to cross into the center before they move on to the north. Yeah. Okay, or we can use either roundabouts or signalized intersection for treatment as well. So again, it depends very much on where is the location and what are the conditions attached to the initial intersection. Okay, even for signalized, not all intersection we can use signalized. Okay, and if it's multi-legs, usually the treatment is either we try to avoid multi-legs, but if no choice, really need to, then we'll have to use that. Okay, so for multi-legs, we can try to realign if possible. Okay, so realignment, this is one of it, or we use roundabout, or we can use signalize, but signalize is not that easy. You will have a lot of phases to design, and the timing that you allocate to green would mean red for others, which mean delay for the rest. Yeah? So you have a lot of delays for your road users. Okay. Yep. So then we move on to traffic control devices. This part, not really. I'm not going to touch on this really much. This is not really included in your assessment. Okay. So I will not discuss too much of this. Yeah, I will not discuss too much on this. Okay. All right. Then moving on to week 5, we look at unsignalized intersection. So in this topic, we were looking into the analysis for unsignalized intersection. All right. So yeah, this is purely what's that? Purely analysis of intersections. All right. And our analysis is based on critical gap model. Okay. So you will need to know. You will need to know what's the critical gap. Yeah, but based on gap acceptance theory. Okay. So if we look at this, what's that? If we look at this intersection analysis, unsignalized intersection analysis, what we want ultimately is to calculate your absorption capacity, which is actually how many vehicles can be absorbed into the major stream. Yeah. So then the formula you have is given here. Yeah, is given here. Just need to be very careful because your QP is in vehicle per second and not in vehicle per hour, right? And so for this one, it is very, how do I put it? Very layout specific. Okay, the analysis is very layout specific. I think you would have known that from your assignment 1 because you would see that um, the different ways that you propose for your treatment would then affect the way how you analyze it. All right. So this is layout specific. Okay. So just remember, you just need to remember that whenever you are calculating for capacity, if you have one lane, one movement, not sharing, you must have one capacity. Okay, so each lane on its own should only have one capacity ultimately. All right, so this is for non-sharing, formula for non-sharing, and this is formula for sharing lane. Yeah, so if you have two movements sharing one lane, then you are calculating with this CT formula. But you still need to calculate the previous capacity because this is then used in this formula here. Okay. Anything else? All right. So then you have the absorption capacity because that practical capacity because we know that not everyone gives signal. Okay. Now there were some questions I remember from your from assignment 1 surrounding the use of QS. Now, when do we use QS? Typically, when we calculate, let me just go to the end. Okay, typically when you calculate your capacity, it is the rest of the calculation, which is your degree of saturation, the practical capacity, the number of lanes and so on, will be based on the capacity that you have calculated. Okay, typically it's that way. So we usually would just use C rather than QS. So then when would we use QS? The service capacity. Now, service capacity is used when you have a movement that gives way to another movement that has also got to give way. For example, when you have this, okay? So if you are calculating for Q2, then we need to use QS, all right? Because this movement gives way to, supposedly gives way to this tree, Q3, Q5, Q4, but Q5 will have to give way to Q3. So you are giving Q2, if you're analyzing for Q2, this is giving way to Q5, which has to give way to Q3. Yeah, so in that situation, then you have to give way to, in that situation, you have to use QS, the service capacity. Okay, I hope that is clear to you. All right, this other example. This one is only one example. The tutorial, I think Ms. Bong has discussed with you all the tutorial questions given in the given in the tutorial. Okay. Any question until this point? Okay, I don't see any question for now. All right, then I'll just move on to the following week, which is roundabout. And roundabout builds on from unsignalized intersection. Okay, so for roundabout side, we have divided that into two parts. One is the geometric design of roundabout, and the second half we discuss on the analysis of roundabout. Okay, so yep, roundabout. Yeah, so first half we look at what's that? Geometric design, where we can make use of roundabouts. Okay, terminologies, I think you should be familiar of that by now. And for roundabout design, usually it's to cater for either capacity and for safety, either capacity or safety. All right. Yeah. Okay. So I think this part. Okay, all this, yeah, turning movement. In terms of geometric design, what we need to consider for your roundabout, especially if the roundabouts are very small, is that you have to consider the turning movements in terms of the design vehicle, because your design vehicle would dictate what is the turning radius, and eventually what is the size of the roundabout that you should be using. All right. Because ultimately what we don't want to see happen is something like this. If you are not designing for it, or if you did not consider over-dimensional vehicles, long vehicles, and you put a roundabout without considering them, a very small roundabout without considering this kind of vehicles, what will happen is that the wheel of the vehicles may just travel on on the central island. So if you have considered that, then we can appropriately address it through our design. perhaps by putting in concreted section, concreted apron, and be considered as part of the. This is also part of the what's that, of the central island. Okay. Okay, so considerations also given to circulating lanes and number of entry lanes. Okay. I won't be asking you to draw a roundabout. That has already been covered in your assignment 1. So don't worry about that. Okay. All right, and then in the second half of roundabout topic, we looked at the performance analysis, where we calculated, or rather where we have to determine whether it is a single lane roundabout or a multi-lane or 2-lane roundabout. Okay, so if you have a single lane roundabout, it is always a dominant lane because your cars, the vehicles just doesn't have anywhere to go except for that same lane. Everyone will be traveling on the same lane. Okay, and then if it is a 2-lane roundabout, multi-lane or 2-lane roundabout, then we will have to determine the dominant and the subdominant lanes. All right, so the analysis should always start with this when you have a turning movement diagram. Okay, so you have to change that into a circulating flow diagram. Otherwise, you will not be able to proceed with the analysis. All right. And then determining number of entry lanes. If you are designing it, then you will have to determine the number of entry lane. If you already have a layout of the roundabout, or it is an existing roundabout, you know the number of entry lanes, and you are just analyzing the capacity, then you don't need to look at this. You don't need to look at this. What's that graph? Yeah. Okay. Then, as what we specified earlier, if it's single lane, there's just dominant lane. But if it is multi-lane, then we'll have to determine dominant and subdominant. What's that? Dominant and subdominant flow. And greatest flow is chosen as the dominant flow. Okay. So typically, although I know in your assignment you had a bit of issue with what's that? A bit of issue with dividing the what's that? The volume into the lanes. But for this class, we will just take it as if you have 2-lane, we'll just make it as this is true and left, and this is true and left. So true is always half of whatever the volume is. Okay, so this usually is our assumption. If it is not stated, you can also make your own assumption, but you just have to state it very clearly. Okay, and all the tables to get the parameters and the capacity. Okay, so once you have the capacity, then comes the performance parameters, such as degree of saturation, delay, okay, queue length, and so on. So all these are all performance parameters to check the performance of your intersection. Okay. But then this is example, and then we had metered roundabout. Yep, that's about it for roundabout. Any question on the roundabout? Not at the moment. Okay, so then if not at the if no question at the moment, I move on to signalized intersection. This is the third type of intersection treatment that we have, or intersection analysis, which is signalized intersection. Okay. So signalized intersection. So when can we use signalized intersection? It's given to you here. If let's say traffic demand, traffic volume is high, and how high is that high? Traffic volume exists 600 vehicle per hour on the major road and 200 vehicle per hour on the minor road. Okay, or you have very, very high, even though minor road is very low volume, less than 100, and we have very high traffic volume on the major road, we can consider putting in signalized intersection as well. Okay, or we have pedestrian, a lot of pedestrians, or we have a lot of crashes in the past, we can also consider signalized intersection. Okay, now for signalized intersection, what is important here is that we want to allocate sufficient green time to all the approaches of the intersection, and to do so without causing a lot of delays to the rest of the users who are waiting at the intersection. Okay, so we have to know that our action by adjusting the green time for one leg would then affect the rest of the legs. Yeah, so green time, sufficient traffic capacity will, within the available road space of one number of lanes, green time, yeah. So it's affected by this. And if we want to increase the capacity of the intersection, we can consider some of these measures. All right, providing exclusive right turn, sorry, and then widening in the intersection, okay, and lengthening the storage space. So these are all measures that we can use to increase the capacity without prolonging the green time for that particular leg. Okay, so other considerations that we have to give for signalized is also to ensure you have sufficient swept path, okay, sufficient clearance for swept path, and then storage lane, pedestrian faces if there are a lot of pedestrians, okay, and then medians can be used for pedestrian shelters, all right, and sufficient turning radius if the intersection is small, if the signalized intersection is small, and you have to cater for large vehicles or long vehicles. Okay. Yeah, so control type for signalized, we have traffic actuated type, we have semi-actuated, and we have fixed time cycle. So these are all these three: traffic actuated, semi-actuated, and fixed time. These are for single intersection. Okay. Then we have the area traffic control. This is area wide, and this would consist of several intersections to be coordinated. Okay, so we need detectors in the signalized intersection. right, so the detector's location, okay, so it's either placed in advance and at the stop line. Yeah? So one type is in advance and the other type is at the stop line, right? Okay. I'll fast forward this a bit. Okay, then in terms of the performance analysis for signalized intersection, we went through some of these terms. I will not go through the terms now. Okay, we started off the analysis with signal phasing. Okay, so this signal phasing would depend on a couple of things. Okay. Yep, it will depend on the intersection geometry, whether how many number of lanes do we have, whether the lanes are sharing or not, what is the angle of approach. Yeah, so it will depend on that, okay? And then, of course, it will depend very, very much on the traffic flow rates composition. Okay, if we know the traffic flow is very, very high, then we may choose to have phasing that if this is a T junction earlier, we may have to prolong the green time for some of these phases. Okay. All right, and then we have pedestrians. Okay, that will be in considerations as well, because pedestrian may, if you have few pedestrians, it's okay. You don't design specifically for them. But if you do have a lot of pedestrians, and I mean a lot, okay, then you may have to consider phase A, B, C, and a phase D just for pedestrians. Right? Otherwise, if not many, then you can insert it as one of these, or insert into any of these phases. Consideration also has to be given to special vehicles. Your special vehicles here include bicycles, buses, trams, if any, emergency vehicles. Okay, so these are all special considerations. All right, and whether the system is going to be coordinated or not. Yeah? Whether the signalized intersection is going to be coordinated with the next signalized intersection or not. All right. Okay, we have this. Right turn. Now this is a simple two-phase. I don't think you see this a lot in Kuching. I don't recall seeing this in Kuching actually. Okay, then we have the signal model, because the calculations, the analysis is actually depending on, is based on this signal model. All right, so what we see in the signal model is that at this stage, this is intergreen. Okay, so once the intergreen has ended, the intergreen consists of yellow, and all red. All right, and once the intergreen has ended, then the green time would start. Yeah? But we also know that for green time, when the traffic light display green, the vehicle doesn't move immediately. Even if it moves, it is still very slow. It's still picking up speed. Okay, so we have a bit of start loss at the beginning. Okay, and only after a couple of minutes, after a couple of seconds, then all the vehicles will pick up speed and will be traveling or cruising at quite a steady pace. Yeah? So that's where the saturation flow has been reached. All right, so saturation flow, and towards the end, when the traffic light turns yellow, drivers will still keep on moving, and they may come to a stop, yes, but they will still be moving. Okay, so we have a bit of gain of time at the end. All right, so because of that, then we have this effective green time. Okay, so our calculations or our analysis is based on this model, because then we have to determine what's the green time, what's the saturation flow, what's the intergreen, and then only then we can determine what's the display green time. Yep. Okay, then saturation flow is determined based on this. The saturation flow has a base saturation flow, which is the ideal condition where maximum rate of departure across the stop line during green. Okay, so this base condition is obtained from this table. And then you have correction factors to fulfill. So the correction factors are lane width, then the gradient factor, and the traffic composition factor. Okay. Right, then after you have determined the saturation flow, only then you can calculate or determine the capacity. And once you have already determined the capacity, then you can determine other performance parameters. So your performance parameters, degree, excuse me, degree of saturation, flow ratio. So all that will be your performance measure. Okay. So all these are mostly the formula used to determine the different parameters. Okay, so at the end of the analysis, then we looked into timing diagram. So this would show very clearly the cycle time and the green time for each phase, the yellow and all red and red time. Okay. So with this timing diagram as well, with the timing diagram, we can also make use of this timing diagram for coordinating the traffic signals across few different intersections. Okay. Yeah. So I've said just now, more green time given to one phase, the less it is for others. Okay. Then calculating the cycle time, the practical cycle time, and delay. Okay, so delay there are two, with queuing and without queuing. With queuing means it is vehicle because they have to queue, they have to be positioned one after another, so they are in a queue. Okay, without queuing, that is for pedestrians. We don't queue. We'll just stand where we like. All right. So then, yeah, so what will influence the traffic performance in terms of degree of saturation, in terms of the queue length, the timing, and so on? Yeah, so what will influence it is if we have lane sharing, that will influence the traffic performance, okay? If we have short lanes. So just now at the beginning, we put it, if you want to increase the capacity of your signalized intersection, we lengthen the short lanes. You increase the short lanes, then you can accommodate more vehicles on it. Okay. Filter turns and when pedestrian times constrain phase times. Yeah. If you have a lot of pedestrian, they will take up more green time, and that would mean more delay onto your vehicles. Okay. Overflow queues. And overflow queues is then associated with blockages because the queues are piling onto a different lane, and therefore it will have blockages. But these blockages can also mean blockages after you've crossed the intersection, and you have blockage at the downstream of your intersection. Okay, Sidra, we're not going to touch that. Right, then, yep. So just now I said the timing bar, the timing diagram can be used for signal coordination. Okay, so when we do signal coordination, the challenge is for us to allow as much green time as possible, so that so that drivers can actually drive through a few intersection having green time, yeah? At least for the first few vehicles. Okay. Yep. So that's pretty much it for signalized intersection. And the last topic that I'll touch on is on pedestrian transport, a short topic. So this one, I think, should be able to remember better because it's towards the end of the semester. Okay, so pedestrian transport, we discussed from 3 aspects. Okay, one is on pedestrian facilities, all the different facilities, which is classified into time-separated facilities, physical pedestrian facilities, or grade separation facilities. All right. So time-separated, this is meaning to say if pedestrian moves, vehicle cannot move. If vehicle moves, pedestrian cannot move. Okay. So you allocate time for pedestrian, you allocate time for vehicle. But physical pedestrian facilities, these are just to help the pedestrians to cross the roads. It doesn't allocate time to the pedestrians. It is there to help to make your decision easier, to facilitate crossing physically. Okay. And grade separation, this is the best because then pedestrian go on its way, vehicle has its own time, so they don't clash with each other. Okay. So time separated facilities, we have zebra crossing. These are used for very low speed environment, typically 2-lane, 2-way. Okay. If you look at the speed, vehicle speed less than 50 km per hour. Right. And then we have wombat crossing. This is a zebra crossing, but a race type of zebra crossing. Okay, then we have children's crossing. Then at higher level, higher road level, road hierarchy, we have pedestrian actuated traffic signals. Okay, this is mid-block. Yep. Okay, and a modification of the pedestrian pedestrian signal is pelican crossing. Okay, incorporating flashing yellow display. And then we have puffing crossing, incorporating infrared detectors, right? So this will be more responsive for your pedestrians. Okay, we also have pedestrian crossing at signalized intersection. All right, so just now the earlier one was at mid-block, not at intersection. Right, then we have pedestrian facilities to help the pedestrians cross safely or safer. Not to provide them time, but to allow them to make reduced the number of decision making. Okay. refuge islands, refuges or refuge islands, pedestrian crossing at roundabouts. Again, this is to facilitate crossing. And then we have extended curbs. Okay. Then we have grade separation, either overhead bridges or subways. And then in the second half of pedestrian topic, we look at providing for people with disability, right, based on DDA 1992. Okay, and this part we have to design either ramp or walkway. Okay, and the design requirement shall conform to AS 1492. All right. So for all the gradients that are designed, it shall be less than what is stated here. Okay. So now you can either have ramp or a walkway. If you are designing a ramp, which is then determined based on this gradient, the gradient that is used, then if it is a ramp, then we have to put in handrails. Okay, but if it is walkways, it's on these gradients, then we don't need to put in handrails. Okay, and then we also have curb ramps. Right, and then the last bit would be facilities for those who are visually impaired or those who have hearing impairment. Okay, so audio tactile push buttons, these are for hearing impaired person. And we have tactile ground surface indicators. These are for visually impaired persons. Okay, so then you have TGSI would then warn of any pending obstacles or hazards in front, if there is any changes in the direction used or continuously accessible path of travel, okay, to assure them of that. All right, so we have given you the examples, directional tiles, hazard tiles, and I think these days most of the new buildings, major buildings, are equipped with this. Okay, so we see that you have all these hazard tiles here. This is a hazard tile. This is to indicate direction changes in direction, because you have it is next to a directional tile. Okay. Yeah. Yep. So here again, this is hazard tiles. Okay. Changes in direction. Right. And yeah, that's the last bit. Any question so far? Okay, I don't see any question. Yeah, I don't see any question so far. Thanks for your responses. Okay, so yeah, I'll just move into your final assessment. What's that? Scheduled in June, during the assessment week. Okay, your final assessment is 20%. Because your coursework is already 80%, so the final assessment is 20%. and it will be marked out of 20 marks as well. So that means 1 mark is 1%. Okay. How many questions we have? We have 5 questions, all short questions. Total of 5 questions. The weightage varies for each question. All right, and it should be around that 8 weeks topics. Okay, so as I said, rail system is not included, and earlier on I also mentioned what's that? Traffic control devices will not be included. Okay. Of course, I will not ask you to design a full roundabout as well. That has already been covered in your assignment 1. Right. So, okay, the format, like I said, there will be sorry, there will be short questions. Yeah. Short questions in the sense that you have to answer it, not a long essay type of question. Okay, it's just a couple of points, a couple of marks. So you are not expected to give me 5 pages of answers for one question. Okay, so it's sufficient to have some short question. You can also answer it in what's that? In point forms if you like. Okay, and it will consist of both discussion questions as well as calculation questions. Okay. Yeah, so calculation questions would then you will only be asked to enter the final answer. So the intermediate steps that you do the calculation will not be seen as part of the, or how do I put it, will not be entered into the entire Canvas system. Okay, so what I'll do is that I'll open up another submission link. If you have any working, you can submit it there. Okay. Now, if let's say your final answer is wrong, I will look at your working, and if your working is correct, I will still award marks. Maybe not a full mark, but at least there will be some marks. All right. So, yeah, I am not requesting that you must submit it, but if you submit, then at least I can check for your calculations. All right. Okay. Our final assessment, how many questions? I think I've answered that. That will be 5 questions. Okay. So the exam is until pedestrian chapter. Yes, until pedestrian chapter. That's right. So week 1 to week 8. So 1 to 8. This is 7. This is 8. Okay. Now I will be on standby. I will be on standby on MS Teams if there are any questions from you on that day, or if you experience any issue at all. If you do happen to experience technical issue, hopefully you don't, but if you do happen, you can screenshot it and then send it to me. I can give a bit of consideration to lengthen the time a bit if necessary. Okay, not guarantee, but case by case basis. All right. What else do I need to say? Okay, formula wise, I will try to put it together so that it's easier for you to refer to. Yeah. Right. Backtracking will be allowed. Yes, it will be allowed. Yeah. So you'll be able to see the entire flow. Are there more discussion questions or calculation question? There will be more discussion question. I think the can't remember exactly what's the weightage, but I think it's geared towards more of discussion question. Well, this morning somebody asked me how what's that? Any tips for scoring high marks for your assessment, for your final assessment? So my answer to you is, one, don't cheat. Two, don't Google search online, because if you do, you are wasting your time, and you will not have enough time to answer the rest of the question. And also because I can see when the same answers are repeated between the different students, I can see that you are doing that. All right, revise beforehand. Okay, it's important to revise beforehand, even though I know I don't invigilate the assessment in a way. You still need to know um, where the questions are coming from. Okay. What else can I say? Know the application. All right. Know the applications. What else? Answer everything. Then chances to get higher marks will be there. If you leave blank, definitely it's 0. Right? How long is your final assessment? I think if you check from your from your timetable, the final assessment timetable, you are given 1 hour 25 minutes. It's actually 75 minutes for the assessment, and I add on another 10 minutes as reading time, so a total of 1 hour 25 minutes. Okay. So the link will be made available on the day of the assessment. And what else do I need to inform you? Yeah, I think roughly that's about it for assessment, for your final assessment. I will try my best to give back all the coursework marks to you. I'm not sure when, but I'll definitely give it back to you. Okay. Yeah, so that one you have to wait for my announcements. Yeah, I'm still hooked up with a lot of other things. The most pressing one is FRP conference next week. Is the final assessment on 6th June or 13th June? Why are there 2 dates? Let me double check, okay? Just give me a second, let me double check. Yeah, it's on the 9th, I think, if I remember correctly. But let me double check, okay? I just open it. Yeah, it's on the 9th at 1 o'clock. Yeah, it's on the 9th, correct. 1 o'clock and 1 o'clock to 1:22. Sorry, 1 o'clock to 2:25. Okay. Yeah, I will definitely post all the details on the 9th and so on, so that you won't miss it. But luckily you asked now. Any other questions on that? So 9th is a Thursday, yeah? Thursday afternoon. Okay, if there is no other question at the moment for your final assessment, just a couple of things from me. First off is your assignment 4. This will be the last assignment before your final assessment. Okay, so this is on real system as well. It's short question. I've already made this available, so you should be able to view it, and this will contribute 15% towards your final result. Okay, and there are a total of 6 questions for you to do, and yeah, this. So if you look at it, your real system, we spent about 3 weeks, about a quarter of the semester on this. So the marks 10 plus 15. So that's about a quarter of the marks as well. All right. So I've decided not to include this into the exam, or rather into the final assessment. Okay. So format free and easy. You can just type it. You have this question and then type your answers in. Yeah, free and easy format. All right. The last question, number 6, this is calculation question. So do show intermediate steps so that I can understand what you are trying to determine. Okay. Yeah. So hopefully you can do this. All right. So due is in tuition week 2, which is next week, 5th June. This is Sunday, not the usual Friday deadline, right? Any question on assignment 4? I don't see any. So I think this one should be straightforward for you to do. It is meant for you to do. Okay, so the next thing, I've just made this available. The next thing is for this is an invitation to participate in online questionnaire. Okay, now this is a project of mine where, if you recall, in your assignment 1, I've given you video footage of the intersection of the roundabout that was shot using drone. Okay, so I have acquired some fund from Swinburne to actually purchase that drone to be used in this unit. All right, so with that money, I was able to purchase the drone and to give. I was thinking that at least that will give you um, some experience in planning your traffic survey, and as well as a little bit of field experience, because I can't bring you all out to the field and do the field work. So I thought at least that would help to bring the field work to you, to bring the field to you, for you to work on, and hopefully learn something on transport planning, on transport traffic studies in this unit. Yep. So now I have to ask your feedback. What was your experience using that? Did that give you an experiential learning? That means, did you get to experience it? As how did that? What's basically, what's your feedback on that? All right, so that then I can tell and inform back to Swinburne, look, the money that you have given to purchase the drone was actually used and used for the benefit of the students, that is you, and hopefully whatever experience that you have, we can inform back to the management and let them see the money that they have invested has this output. All right, so I'll just go through with you a little bit on the project information. All right, so the project title is actually using drone to enhance experiential learning for this unit, Transport Engineering Unit of Study. And the investigators are myself and Miss Bong, who is teaching into this topic. She's the one who actually make use of drone for traffic studies. So I've roped her into this project. Yeah. And we know that drone has been, the usage of drone is increasing. Okay, so what I've put here is that the project will investigate the potential use of drone in bringing real-world problems into transport modeling assessment in this unit. Okay, and transport modeling requires extensive traffic environmental data, which is very difficult to be provided to the students due to limitations associated with cost, logistics, off-campus fieldwork risks. Okay, so if I were to bring the whole bunch of you out, the 50 plus of you out, then I'll have to scratch my head over this. Costs to bring you out, logistic arrangements, how to bring you out, and all the risks involved because you are at the roadside, you will be all over. Yeah, so it's quite risky. And this can possibly be solved by drone to record the traffic flow at the intersection. Okay. So you are invited because you are in this semester, you are enrolled into transport unit this semester, and the drone was used for your assignment. All right. So for my point of view is that I want to look at the effectiveness of using drone in your experiential learning, in your learning. Okay. And I want to explore, what do you think? What are your perceived benefits? All right. And of course, for myself, I want to document my teaching experience with these, the application of drone-based learning. Okay. So yeah, this project, this is funded from Siemens Sarawak Learning and Teaching Grant. So then what I would like you, or what information that we are seeking from you is that, one, help to do the questionnaire, the online questionnaire or survey. Okay, so this will take approximately about 10 to 15 minutes to complete. And it will ask a little bit on your background. Have you been using drone, your experience with online survey, online learning and so on. Okay, your semester, what is your semester? Yeah. For the online questionnaire, there is no name required, right? And then I am also asking you to use your reflection report. This is your assignment 2, the individual reflection report. Okay, so you have already completed that as part of your assignment 2, and you are not required to do anything further. However, what we would like you is for you to give your consent so that I can use some of the written points that you have inside your data as part of the report. Yeah, because questionnaire is very just rating, strongly agree, disagree, and so on. Yeah, but I don't know, how do I put it? I don't know what you have to say. Yeah? So your reflection report then would at least give me an idea what you have to say. It's more free and easy rather than a very structured questionnaire. Yeah. Okay. And the other one is to use the aggregate marks, average marks for these two components from your assignment 1. One, we are not asking for written consent. You just I'm just asking you, is that okay for you all? It's an average mark. I don't want to know whose mark is this. There's no individual marks involved. It is just average marks. Yeah. I hope that is okay with all of you. Can you just give thumbs up as indication? Oh yeah, thanks for the love. Thanks for the indication. Okay, so basically, so now is actually on the online questionnaire, and then a consent for reflection report. Okay, so your participation in the online questionnaire, there's no direct benefit to you actually. It's just to help me out a bit. Okay, and privacy issue, if you are wondering, will your name be identified? Will you be identified particularly for reflection report? No, it is only me who will be able to identify you. So what will happen is that once you give me the consent to use your report as part of my report to Swinburne, I will decode your name. Okay, I will use pseudonym, meaning to say, you won't be named as Elizabeth Chong. You will be student 1, and you will be student 2. You will be student 3. So nobody knows who is student 1. Nobody knows who is student 2. They only see student 1 said, this project has been great, or this project gives me satisfaction, or this project gives me an idea what I should be doing out in the field, so that we capture that kind of comment in the report, right? Okay, so this will then, once you complete the questionnaire, it will be linked to the consent form for reflection report in another questionnaire, but it is linked, so it's kind of like one questionnaire, one survey link only. Okay. Yeah, your participation is totally voluntary, and there is no consequence if you decline this invitation, or if you want to withdraw, or if you don't want to participate. That's totally voluntary. Okay, but I'm hoping that you will help me. Yeah. All right. So if you click on the link, yeah, if you click on the link, it will bring you to the questionnaire site. And if you give consent, if you click on yes to give your consent to participate in the questionnaire, you will be directed to another page to answer the questions. The first part is the demographic question, and then followed by ranking, disagree, agree, strongly, disagree, agree, neutral, and so on. Okay. And if you click no, you don't want to answer the questionnaire, you will be directed to another page, which is the consent on the reflection report. Okay, so if you give consent yes, for me to use your reflection report, then I will, the question will ask you for your name and your student ID so that I can retrieve the report out. All right. If you don't, then the form will just end. Okay. So, yeah. So the research output is that the findings from this report, like I said, the money comes from Swinburne. I have to report back to them. So we will summarize all the findings, or whatever you put into the questionnaire, and your report, reflection report, will report it back to the executive dean of academic of our campus, which is Professor Sim Kwan Yong. Okay. And we may also think of publishing the findings in journals, right? Yeah, so this project is actually approved in terms of ethic committee has approved the project under this reference number. Okay. Yep. So the link is here. I hope that you will help me out by filling in the questionnaire. Okay. So yeah. Number 6, in your country, which side of the road do the drivers drive on? In Malaysia, we are driving on the left side. In US, if you're coming from countries that are similar to US, they are driving on the right side of the road. Okay, so ours is on the left. Okay, so this is on this project. All right, and I thank you in advance for participating in this project. Hopefully, I'll get a good number of respondents from all of you to show to the management that, look, the class has hopefully enjoyed it. Okay, and anything else from my side? Oh yeah, what's that? Um, I think I'm bombarding you with surveys this evening. What's that? The student feedback survey is already open, and I think the last I saw on Monday was 11 of you have completed the student feedback survey. Thank you very much for that. And if you have not done so, please give your feedback so that I know what was your experience in this unit. And also, if there is any improvement, welcome to give your suggestions in the feedback. Okay, it's totally anonymous for that feedback survey, both on the unit and on teaching. All right. If you feel that there's nothing to improve on, well, maybe you can consider giving 10. Yeah, but it's totally up to you. All right. Uh, any other things from you all? Well, I hope you have enjoyed the semester. I know it is tough semester, and I also have heard that you found that this unit is quite heavy, quite challenging. But I hope that it has given you a good experience and as well as something that you have learned from this unit. Okay. Okay, I don't have anything further, I think. I think that's all I have got to say today. So if there is no further question, I think we will end it here. All right. Yeah. So I'll still be available. And I'll be available on MS Teams on standby during your final assessment. Okay. And if you still do have questions, feel free to get in touch with me. I will reply you definitely. Okay. Yeah. Right. So if nothing, then we will see each other again, probably on campus somewhere, sometime around. Um, if I accidentally don't recognize you, do give me a buzz, a smile. All right, so with that, my apologies as well if there is any shortcoming on my side. If there is anything that I said that has you don't agree with it, my apology on my side. All right, so I wish you all the very best in this unit as well as in your other units and in your coming semester. All right, maybe some of you we will meet again as in the final year project, perhaps, I don't know. Yeah, but I'm open to discussion for FRRP if you like. Yeah, but that's story for another day. Okay, so take care, everyone. It has been really nice to see some of you, most of you this semester. All right, take care till we meet again. Bye bye.